Okay, so remember that assignment from yesterday, which was page 45 in your booklet, is due for marks. A couple of you handed it in. If not, you need to get that handed in today. And there's still a few of you that are missing page number 33 and 21. Chloe, I don't have your page 21. Sorry, yeah, page 21. I don't have that from you. Right, so remember that everything is on PowerSchool as far as what's been taken in for marks. So you should be looking on PowerSchool on a fairly regular basis, see how you're doing, see if you've got stuff missing, and make sure you get it in. Right now it's a blank in PowerSchool, but at the end of the semester, anything not handed in will go in as a 0, and your mark will go down as a result. So your responsibility to be kind of always making sure that you've got all your stuff in that needs to be handed in. Also remember that on Tuesday, we're going to have a quiz on 4.3, 4.4, and then we'll be starting chapter 5 after that. Okay, or actually we'll probably start chapter 5 that day, and then you guys will write your quiz so that you'll have time to write it. Okay, so that's what we got going on. So we're going to finish off the last 2 days of this chapter talking about rational and irrational numbers. So we've already talked about these a little bit. Rational numbers are any number that can be expressed as a fraction in the form a over b. So you can see 3/4, obviously that's a fraction, that's a rational number. 7/8 is a rational number. But also, well, I should say 2/3 as well, but some decimals are also rational number. If it's a terminating decimal, meaning the decimal stops, that can be written as a fraction. If it's a repeating decimal, so this number at the top, 9.454545 dot dot, the 4 5s are repeating. That can also be expressed as a fraction, right? So that's what a rational number is. And within the set of rational numbers, we have integers, which are positive and negative counting numbers. And the reason root 49 is there because the square root of 49 is 7. That is a positive counting number. Integers do not include any fractions or decimals, right? For those, you're looking at rational. Whole numbers are positive counting numbers, including 0. Natural numbers do not include 0, but all positive counting numbers. Irrational numbers, and we've talked about this, those are numbers that have decimals that don't repeat and don't terminate. Pi is a special irrational number. It's a decimal 3.14, but it keeps going on, and it actually never stops. It never repeats, it never terminates. The square root of numbers that are not perfect squares are also irrational, like the root of 10. The square root of 10 is a decimal. Now, your calculator has only so much room in it to put digits, and then it's got to stop, and it rounds off the last value. This calculator screen has as many digits as this calculator is set up to show. There's no repeating decimals here, no pattern there. So this is a non-repeating, non-terminating decimal. That is an irrational number. Same thing as the root of 2 or the root of 3. If you do those both in your calculator, you'll get a decimal that doesn't repeat and doesn't terminate. It is an irrational number. So we've talked about these already, and we're going to spend the next 2 classes looking at specifically at irrational numbers. So on the next page, we have seen that a power with a fractional exponent like x to the 1 over n can be written as a radical or an irrational number. Remember, when you have an exponent that's a fraction, the bottom number tells you what root it is, so that would be n. The top number tells you what power it's raised to. So that's why it's the n root of x. And we can put to the power 1 in there. It's not required, but if you do, it doesn't change what it means, because it is x to the 1 over n. So we have a couple pieces that we can label here. So that is the root symbol there. Okay. The radicand is what is under the radical. In this case, it is the x. Sometimes it's a number, sometimes it's a variable. But that is known as the radicand. I guess we can move that down there. And the index is what root it is. The whole thing is known as a radical. The whole thing is known as a radical. So if we put a circle around this whole thing, the whole thing is known as a radical. But the radical has two important parts. The index tells you what root it is. The radicand is the number or letter that is under the radical. So those are the different pieces that we're going to be talking about. You can wait outside for me. Just wait out there till I'm ready to come talk to you. So again, we're going to focus on irrational numbers. We're going to represent, identify, and simplify irrational numbers. We're going to convert between powers with rational exponents and radicals. We're going to convert between mixed radicals and entire radicals. And then we're going to solve problems involving radicals. So that's what we're going to be doing here. Remember, an irrational number is a number that cannot be expressed in the form a over b. It cannot be expressed as a fraction. It also cannot be expressed as a terminating or repeating decimal. So a special irrational number is the number pi. And again, you can see what that looks like in the calculator. It's approximately 3.14, but there's more decimals after that. And again, it never stops with the decimals, and it never repeats. As well, the square root of a number that's not a perfect square always gives us an irrational number. Okay? So we've talked about how the different number systems are linked together. We've already seen a scale like that, or a slide like that. So we're going to focus on radicals. And again, we've seen that powers with fractional exponents can be written as radicals in the form x to the 1 over n. That is the n root of x, or the n root of x to the 1. We've said that the denominator of the fraction tells you what root it is. That's what the index is. And the top number tells you what power it's raised to. And we've gone through why that is true. So down here it says a power can be expressed as a radical in the form x to the m over n. You can write it as x to the 1 over n times m, which we normally wouldn't do. We can go straight from the first expression to the last. Remember, the denominator tells you what the index is. It tells you what root it is. So that's the n root of x. And the top number tells you what power it's raised to. And whether you have brackets around it or not doesn't change it. All this means is you can take the n root first and then raise that to the power m after, or you can go x to the m first and then do the n root after. It doesn't matter. Normally we do the root first to make the number smaller instead of bigger, but they will both work. So the number 2 to the 3/4 could be written as the fourth root of 2 cubed. The denominator tells you what the index is. It tells you the root. The top number tells you what power it's raised to. So we've talked about this before. This is nothing new. Okay? Nothing new. So example 1 says, express each power as an equivalent radical. So the first one, 64 to the 1/2. The denominator tells you what root it is. So denominator of 2 means square root. And when it's a square root, you don't have to put the index 2. You can if you want, but it's not necessary. So it's a square root of 64 to the power 1. And you might know that the square root of 64 is 8. That is true. But the question asks us to write it as a radical. So that's what we've done. Part B, 16 to the 3/4. Denominator of 4 means the index is 4. It's the fourth root of 16 to the power 3. You need to make sure you write that index small and raised. Don't write it in front like it looks like a coefficient. That is not the same as this. When you write it like that, you're saying that's 4 times the square root of 16 cubed. That's what that means. That's not the correct expression. The 4 must be written raised and smaller to show that it is an index. Question C, those brackets are important. The 8x squared is in brackets. It's all raised to the power 1/3. So because the denominator is 3, that's the index, it's the cube root, and the radicand will be 8x squared. It's in brackets, so it's all under the cube root, and it'll all be to the power 1. So that's that expression, written as a radical. Okay? Do those next 3 on your own. We'll check. So, Princess, what'd you write for question A? Call it a radical, you can call it a root. Like that? No. What's wrong with that? You want me to write thing again? I just erased it. Kai! It needs to be raised in small to show that it's the 4th root, not 4 times the root of 10. And then we can put power 1 there. Not required, but the numerator is 1. Question B. Sophia? Okay, you can say the 3rd root, the cube root of. Okay, good. So there's that one. Roddy, what about the 3rd one? Sorry, I just gotta redo this. Again, sorry. All to the power 3. The 8th root of x to the 4th to the power 3. Now you could, if you wanted to, simplify what's under the radical. That would become x to the 12, right? Because when you have one exponent raised to another, you multiply the exponents and keep the base the same. But that's how we convert from a expression with a rational exponent, an exponent that's a fraction, we can write it as a radical. So take a minute and match those together. Match the one on the left, which is a radical, to the one on the right, which is the number with a rational exponent, or the expression with a rational exponent. So the first one on the left, the cube root of 4a. What does that match to? Declan? The one on the bottom? That one down there? Okay, and that is correct. Because the 4a is under the radical, that's the radicand, the 4a needs to be in brackets. Also, because it's the cube root, the third root, that means the denominator is 3, which is true. And there is no exponent on the 4a, which means it's the same as exponent 1, and that's why the top number is 1. Okay, so that is correct. The second one on the left, Brooklyn, D, what does that match to? Is it the first on the right or the second on the right? Huh? The first. You agree with that, Emil? No, because this is the cube root, so that means the denominator has to be 3. The denominator tells you what root it is. The root is the same as the denominator, so it matches to the second one on the right. And that is the correct matching there, because again, it's the fourth root. The denominator tells you what root it is. Because it's the fourth root, the denominator has to be 4. And because the a is cubed to the power 3, the numerator must be 3. So these questions ask us to express each radical as a power. So now we're going back the other way. They are radicals, we want to write them as powers. So the radicand is 4 for question A. That means the base of the power will be 4. And that'll be raised to a power. And remember that the root, in this case the fourth root, that matches the denominator. Because the 4 is cubed, or to the power 3, that matches the numerator. That'll be 4 to the power 3/4. Question B. The radicand is 3. So that's going to be the base when you write it as a power. Because it's the fifth root, that's the denominator. Because it's the 3 is to the power 4, that's the numerator. It'll be 3 to the power 4/5. For question C, the radicand is S, so that'll be the base of the power. In this case, that's the square root, right? No index is written there, which means it's the square root, which means the denominator is 2. The S is to the power 3, so that's the numerator. Right? So do those next ones on your own. So Sal, what'd you write for the first one? 125 to the power, did you say 1/2? Is that right, Keen? Very good. Good guess, Keen. Yep. Okay, the next one. Brooklyn Lorenz, what would you write for that? Is she right, Allie? Good. Cube root means the denominator is 3, the y is to the power 5, so that's your numerator. Kai, what about question C? You agree with that, Chloe? Good. It's the n root, so that's the denominator. The 27 is squared, so the numerator is 2. Good. Okay, so now we're going to start working with these irrational numbers. We're going to start working with these radicals. And we're going to see there are 2 different types of radicals. There are mixed radicals and entire radicals. The difference between the two is this. A mixed radical is a mixture of a rational and an irrational. So on the left, that 3√2, the 3 is a rational number. The coefficient 3 is a rational number because you can write it as a fraction, 3/1. The root 2 is irrational. That's a non-repeating, non-terminating decimal. So this is a mixture of a rational number in front of an irrational. Same thing with 1/2 times the cube root of 6. 1/2 is a rational number. Cube root of 6 would be an irrational. If you take the cube root of 6, you will get a non-repeating, non-terminating decimal. An entire radical is where there is no number in front. It's just a number under the radical, like the root of 32 or the cube root of 2 to the 5th. There is no number or coefficient in front. So you see the difference. A mixed radical is a mixture of rational and irrational, or in other words, there's a number in front of the radical. It's a coefficient, whereas entire radicals don't have any number in front. There's no coefficient. And so we're going to learn how you can convert between the two. And we're going to do this by using a fairly simple law dealing with radicals. Our law for multiplying radicals is this. Root A times root B is equal to root A times B. If you multiply two radicals together that have the same index, remember the index is what root it is, these are both square roots, the root of A times the root of B can be written as root A times B. So what that means is if we can write both of these numbers here, that these are mixed radicals, if we can write both of them as radicals, then we can multiply them together and write it as a single radical. Again, right now, these are all mixed radicals because it's a mixture of a rational number in front times a radical. We want to write these as entire radicals. We want to get rid of the number in front. And it goes up to this rule for multiplying radicals that we're going to use. If we can write both numbers as radicals, then we can multiply them together and state them as one radical. And here's how this works. I want to write 5 as a radical. So you have to ask yourself, the square root of what number is equal to 5? And that would be the square root of 25. And you could get that by simply taking the 5 and squaring it. But I'm sure most of you remember that the square root of 25 is 5. So I'm going to write this, instead of 5 in front of the root 11, I'm going to write it as root 25. Because that is the same thing as 5. I haven't changed the value of the expression, the value of the number. I just changed the form that the number in front, the 5, is written. I've written it as a radical instead of as a rational number. And now because these are both radicals, I can multiply these together. I can multiply the 25 and 11 together and get 275. And there's our answer. 5 root 11 is equivalent to root 275. The difference is that we started with a mixed number, a mixture of a rational and an irrational, and now we have an entire radical, no number in front. So again, I got that 275 by multiplying 25 times 11. That's where the 275 came from. Now, these two should give us the same value. When you take the root of 275 in your calculator, you're going to get a non-repeating, non-terminating decimal. It's an irrational number because 275 is not a perfect square. But if you take the original expression, which is 5 times the root of 11, you should get exactly the same value, and you do. So you can check the answer you get against what you start with. Make sure you get the same decimal. If you do, it tells you that your answer is correct. Okay? All right, so the next one, root 3 times root 7. Again, if we're going to use that law from above, we need to write both numbers as radicals. The 3 in front is not a radical. It's a rational number. We need to write 3 as a radical. So you can ask yourself, the square root of what number is 3? 9. Very good, Keen. If I had a gold star, I'd give you one. Right? So we haven't changed the value of the number. The square root of 9 is 3. 3 equals the square root of 9. But because we have both numbers expressed as radicals now, we can multiply them together and the answer will be a radical. 9 times 7 is 63, so the answer is radical 63. That's the entire radical that should be equivalent to 3 root 7. So we can check that in our calculator. If we take the original expression, 3 root 7 is that value, the root of 63 should be the same value. And it is. So we checked it. Right? Our answer that we got is equivalent to what we started with, so we know it's correct. The next one, 5 root 10. Again, we need to express 5 as a radical, which we did above for question A. 5 is the same as root 25 times root 10. Again, the root of 25 is 5. 5 is the root of 25. They are the same value. But in this case, because we've written them both as radicals, it now allows us to multiply them together, and the answer stays a radical. So 5 root 10 should be equivalent to root 250. So again, we can check this. 5 root 10 in our calculator. Is that decimal? That should be equivalent to the root of 250. And it is. We know our answer is correct. We just checked it. It's equivalent to what we started with. Now the difference for these next ones is that these next ones involve cube roots. So we need to express a number in front, in the case of the first one, the number 2 as a cube root. So you're asking yourself, the cube root of what number is 2? And like we did above, we can work backwards. We can take the 2, and cube it. That means 2 times 2 times 2, which is 8. This can be written as the cube root of 8 times the cube root of 5. The cube root of 8 is 2. 2 is equivalent to the cube root of 8. They have the same value. But now we've written the 2 as a cube root, so now this allows us to multiply the two numbers together, and the answer stays a cube root. That's the cube root of 40, which we can check in our calculator. 2 times the cube root of 5 has that value. That should be equivalent to the cube root of 40. Excuse me. Oh, I put the wrong number in front of that cube root of 5, so let me fix that. I put a 3 in front when it should have been a 2. There we go. Now we got the same decimal. So we know our answer is correct. We just checked it. And again, make sure when you write these that you make sure that the index is written up high and smaller to show that it is an index and not a coefficient. Question, or the next one, 3 times the cube root of 2. Again, we need to write the 3 as a cube root. You need to find out the cube root of what number is 3. And you can do that by working backwards. You can take the 3 and cube it. 3 cubed means 3 times 3 times 3, which is 27. So this will be the cube root of 27 times the cube root of 2. The cube root of 27 is 3. 3 is equal to the cube root of 27. But now because they're both radicals, we can multiply them together. So what would you multiply together here, Brooklyn D? Were you having a good dream, a daydream? Please tell me you're dreaming about math. You're going to multiply the 27 and 2 together and get 54, so this is the cube root of 54. We've expressed it as an entire radical, which again, we can check. 3 times the cube root of 2 is that decimal. That should be equivalent to the cube root of 54, and it is. Four times the cube root of 4. So again, we need to write the 4 as a cube root so we can multiply these together. You need to figure out the cube root of what number is 4. But again, you can work backwards by taking the 4 and cubing it. 4 to the power 3 is 64. So therefore, the cube root of 64 is 4. I'll write 4 as the cube root of 64. And that's multiplied by the cube root of 4. So 64 times 4 is 256. This will be equivalent to the cube root of 256. And once again, like we've been doing, we can check these to make sure. 4 times the cube root of 4 is that decimal. That should be equivalent to the cube root of 256. And it is. So we know our answer is correct. Our answer that we got at the end is equal to what we started with. But again, the difference is there's two different forms. We started with a mixed radical. It's a mixture of a rational and an irrational. We ended up with an entire radical. There is no number in front. There is no coefficient. There's an index because it's still a cube root, but that's not the same as a coefficient. So how are we going to find out what we need to put inside this first radical? If I want to write 1.5 times the cube root of 6 as an entire radical, I need to express 1.5 as a cube root as well. What do I need to do to find out what I need to put under that first radical? Declan? Cube what? That's right, you'll cube the 1.5. 1.5 to the power 3 is that decimal 3.375? And now what do we do, Emery? Multiply what? Yep. And then your answer will stay a cube root. So we take that 3.375, multiply by 6, and our answer will be the cube root of 20.25. Which again, we will check. 1.5 times the cube root of 6. 6 is that decimal. That will be equivalent to the cube root of 20.25. Same decimal. Okay? So you need to understand, you need to know the difference between mixed radicals and entire radicals. You're going to be tested on this. And you need to know how to go from a mixed radical to an entire radical. So again, how do you know? Well, a mixed radical it's a mixture. It has a number in front, a rational number, as well as an irrational. So cube root of 4/5. Would you say that is an entire or a mixed radical, Keen? Don't tell me to wait. Please. Sal, can you help him? Because he's struggling over here. That number there, is that a mixed radical or an entire radical? The cube root of 4/5. Is there a number in front? No. That makes it an entire radical. There's no number in front. There's an index of 3, but that's not a coefficient. A number in front is a coefficient. So Keen, 1/2 root 7, mixed or entire? You don't have to start praying about it. It's not that hard. Is there a number in front of the root 7? Yes, there is. 1/2. You got a 1/2 in front. That's a coefficient. I'm not going to be as rude as Princess to ask, are you blind? I might be thinking it, but I'm not going to say it. Okay, a coefficient is a number in front. It's a number times the radical. It's different than an index. Cube root of 2 to the 6th. Mixed or entire, Emery? Why? Why? You're correct, but why? Because there's no number in front. There's no coefficient. That's how we know. Okay? What about 6 times the cube root of 4? Brooklyn Lorenz, mixed or entire? Because? That's right. And what's the coefficient? 6. There's a coefficient of 6. I'm glad you're not blind, Brooklyn. That would not be good. Okay. Root 42, Princess. Mixed or entire? Why? No. Because there's no number in front. There's no coefficient. There's no 3 there anywhere, right? That's the square root of 42. There's no coefficient. But there's no coefficient, so it's an entire radical. 3 root 5. Keen, here's your chance to redeem yourself. Why? And what is the value of the coefficient? What is the value of the number in front? Are you blind? Oh, I said it. I was supposed to just think it. Sorry. 3, right? Your coefficient is 3. Root 70. Brody, mixed or entire? Because? No coefficient. Emil, 0.2 root 10. Mixed or entire? Because? There is a coefficient. There's a number in front. 0.2. Okay? All right. We're going to stop there. We're going to do some more of this tomorrow. What you need to work on for practice will be page 192 to 195, questions 2, 4 through 6, 7A through C, 11, and 12. So just some things for practice. I would encourage you to do them. I'm going to post the solutions to Google Classroom. Do the practice today because tomorrow we're going to have an assignment that I'll be collecting for marks, and so it's going to help you. If you do the practice today, you'll be better prepared for tomorrow's lesson and to do that homework that's going to count for marks. Now, once again, you guys are going to have a quiz Tuesday. Remember, Monday's a holiday, but we're going to have a quiz Tuesday on the last 2 parts of this course, of this chapter. Can I send Keen over to your class every once in a while just to give me a break?
Why?
Okay. Thank you very much.
Why?
Thank you very much.
No, I'm not.